Okay, so this is page 3 of the network notes, and we need to go through the system calls. So this is section 2 of the notes. Alright, so the first one is the socket call, and the parameters are domain, type, and protocol. It returns an int, which will be a file descriptor or -1 on error. Domain is an int, type is an int, and protocol is an int. So that's an easy one. So for domain, you're typically going to use address family INET for internet. There's also address family INET6 if you want to use IPv6. So address family internet is what that stands for. The type will be either sock stream for streaming or sock dgram for datagram. And the protocol, you just use 0 here and it will choose a default set of protocol layers for you. And so for 0, this will be either TCP over IP or UDP over IP, depending on the type that you chose. It can handle other types of domains and protocols and whatnot, but this is the most common usage. So this returns a file descriptor or -1 on error. Okay, the next system call is bind, which I mentioned before. The first parameter is going to be the file descriptor, followed by the socket address, followed by the address length, and it's going to return an int, 0 or -1. So the file descriptor is an int. The address is going to be of type, it's another long one. I'm going to do it in 2 lines here. Const struct, it's sock address instead of address info struct. So socket adder, and it's a pointer. And then the type for address length is sock len type, sock length type. So we actually have to cast the address that we get back for some of our calls from the address info type to socket address. But anyway, it works. Okay, so the address, really what this does is we use it to specify the network adapter. Whoops. The network adapter and port. So the computer will usually have more than one network connection. It'll have the internal loopback connection. It'll have its wireless connection. It might have an Ethernet connection. It could have IP over Bluetooth and so on. But you can just specify, just use whatever is available, which is what we're going to do. But which port number too is also important. Okay, so that's bind. It returns 0 on success, -1 on failure. And next is listen. Whoops, I want to move that down a line. Listen takes the file descriptor and a backlog count. And the types of all of these are int. So it returns an int, file descriptor is an int, backlog is an int. And the backlog is the maximum number of outstanding connection requests. So if it hasn't called accept for a while, for whatever reason, how many incoming connection requests can the OS kind of keep open until it starts rejecting further incoming requests. Okay, and as it calls accept, it will work on that backlog. So listen returns 0 on success, -1 on failure. You might see a pattern here. And the next call I want to look at is accept. It also takes a file descriptor. It takes an address parameter and an address length parameter. And the types are going to be int, and this is going to be a struct sock adder pointer and sock length type pointer. And what these two parameters do is if you give it a place to write the client address and the address length, it will store that information for you in case you want to know who it is that you're accepting a connection from when you're dealing with them. Maybe you want to log it, for example. If you put null for those two parameters, then it won't write them there. So this is the client address and the length of the client address. And so these are optional. Use null if you don't care about them. And this, again, actually slightly different, returns a new file descriptor for that connection because you're establishing a connection with a client, but you might also want to keep listening for more incoming connections. It will return -1 on failure. And lastly, we have the connect system call, and it takes the file descriptor, and it takes, again, an address and an address length, and the types are, in this case here, this is going to be a const struct sock adder pointer, and this will be sock length type. And this is to request a connection. Whoa, my writing's getting really bad there. And it returns 0 on success, -1. I don't know why I started saying failure. I meant to say error. Anyway. Okay, so two more. This is not really the fun part of the notes. So for if you've created a streaming connection, so not the datagram style, then to send and receive, you'll use, funny enough, the send and receive system calls. And send takes a file descriptor, it takes a pointer to a buffer, the number of bytes to send, and some flags. And the return type is int. File descriptor is an int. The buffer is a const. Before we see in char pointer, in this case it's actually void pointer, which I think makes sense because we don't really know what the type is of the data we're sending. And length is, whoops, size type, and the flags are ints. And for flags, you can make it like blocking versus non-blocking. The default is blocking, or you can just use 0, and we'll use the default, which is blocking. So this is our data pointer, and then this is the data size, how much we want to send to the other end. These are the network options. And there's more than just blocking or non-blocking, but we're not going to get into those here. You might if you took a networking course. And just to note that send fd buff length 0 is the same as calling write on that file descriptor. So, I don't know, just an interesting bit of trivia. You can do it either way. I tend to use send with network programming, but you could use write. So this returns the, oh, you know what? I'm sorry, I have to recount something here. It returns the signed size type, which should make more sense. It returns the number of bytes sent, -1. I'm going to revert to saying error instead of failure. -1 on error. Okay. And send can send pretty much an arbitrarily large piece of data. You don't need to break it up for send, and it should return the same number of bytes that you told it to send. It should not return less than that, or there's been a problem. Okay, then we've got receive, and receive won't necessarily get that same chunk of data all at once. It might get it in multiple smaller chunks because the layers of the network stack might break it up into smaller pieces, and they might arrive in smaller pieces. And so the receiving end has to put them back together. If you're using TCP, they'll come in the right order. So it's not like you have to reorder them, but you have to be aware that they you might not get it all at once. Okay, and receive again has return type of signed size type. Int is an FD. The buffer here is going to be void pointer, not const void pointer, because it's putting the data there. Length, whoops, will be size type, and flags will be int. So it returns number of bytes received, -1 on error, and this is new, 0 if the connection got closed. And that's actually kind of useful. So when you're receiving and you get back 0 bytes, that means the other end closed the connection. So basically, conversation's over. Data may be delivered in multiple segments. And so I'm going to illustrate that with these codes. samples. So big send.c and big receive.c. And I'm not sending that much data, it's just a megabyte. The reason for that is just to make the code easier for the buffering, so I don't have to dynamically allocate it. If I keep it to a certain size, it can just be on the stack. But it does show receiving, multiple chunks and putting them back together. And I would have worked through this with you in class, but because we're online, it's pre-recorded, I'll just show you the finished product.